Hi, my name is Daniel Park, and we're Group 9. We designed the brace members, column, and beams for a 3-story office building with a penthouse level located in Los Angeles, California. The loads that we considered for this design were dead, live, wind, and seismic.
Hi, I'm Frederick Cernattinger, and talking about these loads, the wind and the seismic loads were used in the calculation of the demands on the brace frame members for both the east elevation and the south elevation. And for the beam and column calculations of the demands, the live, the dead, the wind, and the seismic were used on both elevations as well. And then the elevation that had the max load on it was chosen as controlling, and thus the design followed that elevation.
We're going to go ahead and talk a little bit about how we designed the columns and the beams. Each of us designed separate brace members, but for the sake of time, we're just going to speak about how one of those were designed, and then we'll go into who designed which ones and how we found those.
So this is Mahmoud, and I designed for chevron W-shaped brace R=3 for south elevation. After determining the load from SAP 2000, I found that the earthquake load controls, which was 128.6, and using a 992 steel with a yielding force of 50 KSI, I found that the required gross area was 2.858 inches square. So I chose to design for W6x15. The tension axial check was succeeded, but the axial compression didn't. So I chose another size, which is W6x25, which did exceeded the compression check.
Right, next we're going to talk about our column design. We actually had 2 column designs, one for the south elevation and one for the east elevation, but after analysis we found that the column on the south elevation actually controls. So what you see on the screen right now is a summary of all of the loads that were used to calculate the actual load on the member. Tributary areas, pent roof, dead and live load, and wind and seismic loads were used to calculate this. And the final value after using LRFD equations is 460. So this is the value that the column was designed to be able to withstand. So what you see on the screen now is A992 steel was used. The length of the column, as you know, 13 feet. Critical stress limit was implemented to find what equation must be used to design for compression, which was 3.3. FCR value was found and then plugged in to find the required area. After finding the required area, we chose a W10x49 member, and then we went to checking this 10x49 member to make sure that it would be able to withstand that force of 460. And it did, because it has a force of 489.84 kips. So we decided to move forward with our W10x49 for column design.
Hi, my name is Paul Dekove, and this is a summary of the beam calculations and design. So for the south elevation, we have the 36-foot span beams, and for the west elevation, we have a 30-foot span beam. For simplicity, we will have the same beams throughout the design. So we calculated the strength values for each beam. In addition to this calculation, we check the flexures, then we check the shear and deflections of each beam. In addition, for each beam, we use the A992 steel, and this has the KSI value of 50 KSI for the FY component. In summary, we have a W24x76 for the 36-foot span, and a W21x68 for the 30-foot span.
Hi, my name is Daniel Park, and I was responsible for designing a chevron W-shaped member for the east face of the building. Through my analysis, I found that the appropriate size member was a W8 by 35.
My name is Frederick Cernattinger. I also was on the east elevation, and the member that I chose was a W6 times 20.
My name is Alexander DeHart, and after analysis, I chose a chevron shape with a member of W6 by 15.
My name is Mahmoud Al-Wahabi, and I worked in south elevation, and the chosen steel was W6 by 25.
My name is Paul Dikov, and for the south elevation brace frame, I chose the HSS 6x5 by 1.5.
My name is Alex King, and I designed a HSS 8 by 6 by 1/2. I also performed the cost analysis for the project. After I performed the cost analysis project by using the typical cost for steel of $1,600 and then multiplied it by the weight of each steel section. After the analysis, I determined that the cost for the W6 by 15 and the cost for the W6 by 20 would be the most cost effective for our braced members.
Hi, I'm Alexander DeHart, and going to the summary, looking at the south elevation, the column member that we chose was W10 by 49 typical. For the beam that we chose to go across, we chose a W24 by 76. All the beams will be designed this way. And for the chevron member that we individually designed and chose, as stated earlier, we chose a W6 by 15 typical. Moving down to the east elevation diagram, starting at the column, we decided on a W10 by 45 typical. And looking at the beams, once again, all the beams will be the same. We used a W21 by 68 typical. And lastly, for the chevron shape, after analysis, we chose a W6 by 20 typical.
We got to do it over again.
Yeah,
Kiko said actual instead of axle.